Write a polynomial function of least degree with integral coefficients that has the given zeros. So now what they're saying is this polynomial that we need to create, x to the whatever plus x to the whatever, has these zeros. These are the zeros right here, the roots. So if -5 is a root or a zero or a solution, now we're going to go backwards from what we were just doing. If I know the zero, I can create the factor. If -5 is a zero, it comes from a factor x plus 5. And if -1 is a zero, it comes from the factor x plus 1. And if +1 is a factor, if +1 is a zero, it comes from the factor x minus 1. So we're now going backwards and taking the zeros that we were discovering lately, and now going backwards and writing them as the zeros with the factors that they come from. If we know the zeros, we can write the factors that they came from. And now, once we have the factors written that they came from, we can, this isn't a nice way to write a polynomial. It's a nice way to discover what the zeros or roots are, but it's not in standard form, and we should write this in standard form. So, multiply any two of the binomials together. I'm going to choose these two because I noticed that some fun stuff's going to happen. But you can multiply any two together and then bring the third that you don't multiply through down because you still need to multiply that. So it's going to be like 2 steps of FOILing. So we get x squared. I'm going to use red here, I guess. I don't know. X squared, -1x, +1x, -1. And again, when I combine like terms, those cancel out. It's a difference of squares. Alrighty. So usually you're going to have one more term in this red solution that I just got. But that stuff, folks, oh no. This stuff right here is the simplification of multiplying those last two binomials together. But they still need to get multiplied by this x plus 5 and this x plus 5. So when you have a third term in there, it's going to make a little more work for you, but you can handle it. So we get x to the third minus x plus 5x squared minus 5. And now let's write this in standard form, or at least when you do your multiple choice test, it will be written in standard form because that's what we do. And there you are. There is number 31. Let's try number 32. Mr. P got excited on that one. He's going to have to write a lot smaller. So, again, these are zeros, or roots, or solutions. -2 comes from the factor x plus 2. -3 comes from the factor x plus 3. And -4 comes from the factor x plus 4. Now that I don't see any difference of square situations, I'm going to multiply the first two binomials together. I'll have to do a little simplifying, and then I'll get a nice, neat, probably trinomial here. 3 terms. So we get x squared plus 3x plus 2x plus 6. Combine your 3x and 2x to get 5x. This is now what we're working with, but we still need to multiply that by that x plus 4 that I didn't multiply through yet. And so, folks, when I have a trinomial times a binomial, I really like to distribute the terms from the binomial in. So when I multiply just the simple x in, all it's going to do is increase the degree of each of these terms in the green by 1. So it'll be x to the third, 5x squared. And then the constant of 6 goes to 6x. Then I personally like to then distribute this, and that's a preference, folks. I find that I make fewer mistakes when I do it systematically like this. Then we get 4x squared plus 20x plus 24. Oh, that's a 4, that's a 4. something that some people do, folks, is they realize they're going to have some like terms. So when they get the x squared term, they put it underneath the existing x squared. They put the 20x underneath the 6x, and then the constant sits out here. So then that way it's kind of like elementary school where you add vertically, and this way you have your like terms already combined. It's a slick way to see your like terms and organize your like terms. Just a little trick for the toolbox. Oops, 20 plus 6 is 26x, and then plus 24. If, this is kind of cool, folks. Don't go to Desmos Grapher right now. Check this out. If you punch this polynomial in right here, you should find that it's going to intersect your x-axis right there at those spots. It is pretty darn sweet. Oh geez, we've got some radicals coming up, folks. Let's look at those. Let's try a few more of those, folks. And yeah, we have some radicals here. But don't panic. We can handle it the same way. So again, these are the zeros or roots of the solution. If -3 is a 0, it comes from the factor x plus 3. If the square root of 6 is a 0, it comes from the factor x minus the square root of 6. If -6 is a 0, it comes from the factor x plus the square root of 6. So now we do the same process. I'm going to choose, again, kind of like on the first one I did like this. I see that these are conjugates of each other, which means that we get to, when we simplify, it's going to simplify nicely, and there's going to be a term canceled out. If you don't do it with these two first, you'll eventually get the right answer, but it's going to be a lot more work. A lot more work, because you won't get that canceling right away. You'll get it later on. So, I'm going to distribute the x, so we get x, and the square root of 6 times x. Make sure you know what, that's not a good idea. I'm going to write x square roots of 6. Because we don't want that x to look like it's inside of there. Then distribute the negative square root of 6 through. See that negative, folks? Negative x square root of 6. When you multiply two things together and one's positive, like a positive x times a negative, you get a negative. And then last but not least, we have negative square root of 6 times square root of 6, which is a -6. Just like that. Because really we would have a negative square root of 36, and the square root of 36 is 6. So when we combine this, we just get x. Ooh, that's supposed to be an x squared, right, folks? X times x is x squared. It's good. If you're getting enough practice, folks, you realize that that looked silly when I just had an x down there, and it's also wrong, but just the silliness of the looks of it can help you catch that boo-boo. And then, folks, but hold on, we're not done, because we have this x plus 3 that we need to multiply with everything. So now we get x to the third, negative 6x, 3x squared, positive 3x squared, negative 18. Let's write it in standard form because we're mathematicians. That's what we do. There we are. How does that look? Beautiful. I'm going to do one more with these radicals, folks, just to give you a little more guidance with it. Let's roll. Let's try number 35. So number 35. So if this is a 0, it comes from the factor x plus 4. If this is if the square root of 7 is a 0, it comes from the factor x minus the square root of 7. And if negative square root of 7 is a 0, it comes from the factor x plus the square root of 7. Those are conjugates. Let's multiply them together first. So we get x squared, positive x square root of 7. That's from this distribution. Now we get negative 7, the square root of 7 that we're distributing through. So negative x square root of 7. And then negative square root of 49. The square root of 7 times the square root of 7 is the square root of 49. Square root of 49 is 7. So it's a negative 7. Now we take this stuff and we combine it, or we simplify it, and we can simplify the middle terms. They are like terms, exactly the same, but one is a positive one, and one of the terms is a negative one. That makes 0 of those terms. So x squared minus 7 is all we got here. Don't forget to multiply that by the x plus 4 that we left hanging out in front. This is all multiplication of these factors. So we get x to the third, negative 7x, plus 4x squared, minus 28. Write it in standard form, highest degrees first. And there we are, folks. Again, you can try some more of these, and there are answers down below.